good afternoon, good morning, good evening to Europe, good evening to Africa, good morning maybe to Australia, good night to Asia. But look at this. Look at this view of a kitty cat. We're back. We're live. Thank you for joining the live. Welcome, welcome. There is an extremely sunny day today here in Boston, which hopefully melts this snow that's on the ground and makes it so that we don't have to pay for snow removal up front on the sidewalk, which has led to a fine for me, in fact. And also, so that I don't have to scrape my car too much, this sun shall melt the snow, hopefully. So we're very thankful for this and excited for a sunny live. Look at an extremely cute kitty cat, Sleepy Deepy, over here. Hi, Ram Candy, says Baji. We did land on the moon, says a reminder. We absolutely landed on the moon forever and ever. Ram Candy says, first like. Thank you so much for liking the live. Thank you so much for being here. If you're seeing this video as a video upload later on under the live tab of this friendly channel, then welcome, and appreciate all of your comments in advance. Look forward to reading them on the dashboard as always. Thank you, Heike. Thank you, everybody. Our regular VIPs in the live. Ram Candy, the moon landing people, Dr. Sias. This channel is full of truths, says Dr. Sias. This channel is indeed full of kitty cats and truths and physics and astronomy, and today we are going to talk about the planets again. And in fact, we will talk about a planet that we missed last time, which is Mercury, of course, a planet in our own solar system, closest to the sun, apparently with no moons. And we will learn more about it. We, of course, had a Venusian chat last time, as well as a little bit about our own home planet, the Earth, as well as Mars. Today, we will talk about more things like that. But first, we will catch up with all of you in the chat. Lovely to see everybody. Lovely, lovely, lovely to see you all. Thank you for joining. I will give everybody a shout out if you especially leave a kind message that is, readable and children friendly and family friendly. Gurjar Harsh says, Happy USA. Thank you. Talking about your Uranus, that is a planet we will cover. Ajay says to talk about Uranus. Dr. CS is saying that Uranus is a good planet. It's deep and I see making some jokes. Gurjar says happy. I am Batman says hi. I am Batman 713. Astrology is insane. Well, this is going to be more about astronomy. We did land on the moon, says there are moons, we just didn't land on the moon of, you mean we did not land on the moon? Yes! Oh my gosh, you're correct. We did not land on the moon of Mercury because there is no moon of Mercury. Ajay says, sorry, I'm Batman, says lol. Purcell, hi Purcell. I'm Batman, I am Batman, got it. There's a moon on Earth. Well, there is a moon off Earth. I've heard that among all the planets, Uranus is your favorite planet, apparently. Ajay. Dora says, listening while I play video games before gym. Good to hear the debates kicking up. Doro, I have given a twist to some of these comments that we're getting on the live chat. So unless you're reading, you're gonna get a filtered version. And it's okay if you're playing video games, go ahead. You don't have to moderate like usual, because I think I've got this today. I've got the energy to take care of these extremely interesting people that are joining. A lot of them are new, so I'm just kind of getting a feel for this current environment off Earth and this live stream on this extremely sunny Sunday, where we will be hanging out with kitty cats and planets. I Am Batman has a favorite planet that they have announced many, many times. It is a Jovian planet. I will say it is kind of far from the sun, and we will cover it. And if it gives people joy, he did or she did say Uranus. Got it. It's your favorite planet. Okay. Oh, yeah, you're committing fake news. I'm not committing fake news. I'm just giving a twist to some of these ruder comments, making them a little bit more family friendly, because it is Sunday afternoon here in Boston time. And I would not like if people were uncomfortable due to some of these rather twisted things that we're seeing here. I'm sorry, reveal yourself, Miss Kind Soul. Hello, Ajay. You know, there are many, many lives where I do show my face. I don't think this will be one of them. Doro says, nah, just kidding. You will do what you do. Thank you, Doro Madness. I'm Batman is absolutely obsessed with the particular planet that we have been mentioning. And then you're too sweet to be from Boston. Well, I'm not from Boston originally, but at this point, I'd rather, might as well be from Boston since I pay the parking fines here. I'm just going to go with saying that I'm from Boston because that's where I live, but I am originally from a whole different country that you can maybe guess on. And if you're new, and if you're, sorry, not new, then don't tell them where I'm from, because people probably know. Some of the people who are on here. Thank you for liking the live. Thank you for being here. You sound like an angel. I'm sure you existed before Adam and Eve. Look at that. Look at that. It's a good thing Dora Madness is playing video games, because he is usually the mod, and lately he has been extremely strict with people. She's actually beautiful. Yes, the kitty cat. And if you're talking about me, well, thank you so much. I saw her. Wow. Okay. Thank you. What would be excellent is if you could like the live and stay on and continue to chat and listen as we talk about planets going forward here today. I just wanted to get this live started while it's so sunny and while Suji Mama is in such a nice... Suji Mama is in such a nice pose. Look at this foot that is hanging. Guys, I'm sure it'll be... Doro! Just play your video games. You're scaring them. Look at this. They've all left now. But I will say that... Oh, God. I didn't realize my feet were there. I will say that this live stream does have some very strict people, some very... Oh my gosh. Yes, mocking. So this live stream... This live stream... I will just say, because this live stream is for physics, there is a number of people high on sarcasm who will mock you, probably just either, I don't know, behave or grow thicker skin, because I didn't do any modding, just mocking. YouTube's algorithm be wilding. I'm a guy from a different country, different time zone, different race, an entirely different mood. Watching you chill with the kitty talking about Uranus. Oh, yes. So we will talk about the planets. We usually do cover physics, astronomy, cosmology, all of that stuff, along with the kitty cats here on the live. Do you think God can exist even if there was no God in the singularity, but he somehow evolved through endless evolution and time through evolution and AI and through parallel universes until finally it became the supreme being, the ultimate collection of love in the laws of physics, and it loves you? Oh, thank you. Well, thank you so much. I am Batman, and it comes to less in the form of a cat. Yes, indeed. The kitty cats are actually getting a snack at the moment, so they're going to be busy with that. One more look at the snow that's out there, and here they are getting their snack. What's good, everyone? The moon landing happened, and Grimmy was even there when it happened. Grimmy here has been a strong proponent of the moon landing. And he wants everybody to know how much he loves the moon. So anyway, that's where we're at. We will be covering some topics from this book called Foundations of Astrophysics by Barbara Ryden and Bradley M. Peterson. This is what we will be mostly using for our discussion in order to wait, I'm distracted. Kitty cats are gods. How nice. Thank you. The thing about cats, they don't care. Okay. Snow in the desert. I thought you were in Afghanistan. Interesting. I think it's Ajay. Oh yeah, and also I'm Batman. Your comments will get held, unfortunately, and it will give me and Doro some work if yeah, exactly. Anyway, so we will be talking about the planets. Get ready. Until then, hang out with the kitty cats, because we will indeed talk about the planets. And actually, let me just make sure that Suji Mama here is getting ready and settled. And then we will talk indeed about Mercury today. So I'm just trying to make sure that she has a good spot first, because I'm just going to be, oh, look at her. She realized that she can be on the couch head. What are the let's talk about some real scientific stuff. What are the odds of a surviving out of 10 billion what? 10 billion plus 1 quarks. Did you know what happened when Stephen Hawking went to the Epstein Island? I don't believe that I do. You could elaborate on this if you'd like. Doro Madness is laughing, maybe about this Epstein thing. I'm not sure I know what that is, actually. I'm not sure what that is. You could tell us if you'd like. Madeline! Oh my gosh, Madeline, how are you? Of course I remember you, and I haven't seen you in a while. So, guys, be very careful now. There are children in the live chat. Make sure your comments are very, very child-friendly, family-friendly. Suji Mama, yes, her name is S-U-J-I. Epstein talk in this chat will be hilarious. Yeah, maybe hold off. I don't know. I have vaguely remember something about Epstein. I don't know if it's family-friendly or not. At the afternoon live time, it's very likely that there are kids who are joining. So just keep that in mind. 2 types of planets. Oh yeah. So this chapter we kind of covered. No, for real, it's not funny. I'm Batman. I'm trying to stop these evil things happening. Okay. So let's see. Family-friendly topic of, so we actually covered our moon the other day, and we covered Venus, and we covered Mars. We might actually cover that again a little bit. Look at Baji Babu. Look at Baji Babu. Hi, Shona. Madeline, how are you doing? Feel free to also participate in the chat, Madeline, and my other young friends. Don't you worry about everything else that's kind of going on in the chat. You should feel free to jump in, okay? So, let's see. So we will probably cover the rocky planets again, but do you believe in reincarnation? Okay, let's get started. Basically, let's first cover what we mean by the terrestrial planets. For example, as we look at this kitty cat. This live, what we'll do is we will hang out with the kitty cats. We will look at your comments. We will definitely read all your comments, probably. And, you know, I might have to look up and do it from time to time, but pretty much if you're putting something in the chat, I'll probably read it out, especially if it is family friendly. And we will start to cover the planets and especially terrestrial planets. And at this time, which is like the Sunday time for us in the afternoon, especially when it's sunny, it's a good time for a lot of kids to join generally. So this is sort of for them more. And I realized that planets are a topic that, you know, might be good for kids or any family members, really. So that's why this is the timing of that. We also go live at night or sort of later in the evening, which is generally our physics lives, more focused on physics. And usually I'm on there and my face is on there. But right now we're going to look at the kitty cats. So the terrestrial planets in order of increasing distance from the sun. So I mentioned, of course, Mercury is the closest to the sun. Who would have thought Planet Talk would bring the... Yes, the terrestrial planets in order of increasing distance from the sun are Mercury. So Mercury is very close to the sun, 0.39 astronomical units. So the Earth, so I'll tell you one thing right off the bat. The Earth is considered to be, in astronomy, basically we give the distance between the sun and the Earth, this unit called 1 AU, astronomical unit. So basically this AU comes up a lot in astronomy. If you take astronomy now, or if you grow up and take astronomy, or you took astronomy when you were younger, older, whatever, you will see this AU unit a lot. Pretty much it's going to be pretty much you're going to be looking at astronomical units. They come up again and again and again. So Mercury is only at 0.39 AU. Venus is at 0.72 astronomical units, or AU. Earth is at 1. Mars is at 1.52. And those are the terrestrial planets. You'll find out how these are actually the rocky planets. Pretty much after this, all the planets that are the bigger planets, the Jovian planets, are not rocky. We kind of talked about why that is. We might cover that again, as well as your favorite planet, apparently, which is Uranus. But right now, we're going to talk about these rocky planets. In order of decreasing mass, they are Earth. So Earth has the most mass out of these rocky planets. So again, a unit sometimes we talk about is mass of Earth, M Earth. Basically, we might compare everything to this M Earth when it comes to planets. And you will often see that when it comes to stars, we compare things to the solar mass, which is our sun. So our sun's mass is sometimes given this symbol of the sun next to an M. And in verbally, we call that, or, in verbal mode, I just call it M sun. So M sun is nothing but the sun mass, or the solar mass, our own sun's mass. And oftentimes, lots of stars are actually compared to this M sun. And M Earth is basically again, the mass of our Earth. Lots of times, planets' masses are compared to this M Earth mass. So, of course, Earth, out of these rocky planets closest to the sun, has the biggest mass. M Earth, 1 M Earth. Venus is 0.82 M Earth. Mars is 0.11, that is 0.11 M Earth. And Mercury is 0.056 M Earth. So, of course, Mercury is very small. Mercury is very small. Even Mars, which is, of course, a planet of interest as far as us going to another planet to potentially settle in another planet, is, what? Okay. I wasn't paying attention to the comments, but I see some things happening. So Mars, of course, as you know, we are in the talks. With our modern technology, we might try to settle in Mars. We have, of course, sent things to Mars to learn more about it, including with the Mars rover. But it's actually much, much smaller than the Earth. So for reference, it's 0.11 M Earth. So very much smaller. Anyway, and Venus is very much close to the mass of the Earth. And of course, Mercury is very tiny. The terrestrial planets are primarily rocky and metallic bodies. So a little bit of this might be review for people who were on the planet's live stream earlier. But basically, you already probably know this, that of course the terrestrial planet, partly why they get this name is, of course, they're rocky and metallic bodies. They have metal and they're rocky. They've cooled, in other words, in a way to actually make rock. A group portrait shows their relative sizes. We might look at this portrait in just a second here. We'll discuss each of the terrestrial planets aside from the Earth, which we've already covered in the previous chapter. So we talked about Earth a little bit, actually, we talked about the Earth during an earlier live. I don't know if we talked about it extensively. I know we talked about the moon a lot. So we might go back and cover the Earth again, or in more detail than what we have done so far. But pretty much, it's going to be the other rocky planets that we cover in more detail today. Thank you for subscribing. Thank you so much for being here. Welcome, welcome. Welcome to the live. Hi, Ben. Oh my gosh. Oh my gosh. Yay, Ben is here checking in. Thank you so much. String theory, gravitational force. Okay. Hope your Sunday's great. Yes, thank you. Oh my God. Okay. All right. Very interesting chat. Good day, kiddos, says Ajay. Okay. Well, thank you so much, Dora. And but yes, thank you so much for subscribing, everybody. Thank you so much for being here. We will continue. I just wanted to look real quick at the comments, but yes, thank you for chatting. There's a lot, and I see that people are definitely interacting. Okay, Well, thank you so much. We will keep going. We will talk about the planets. Pretty much, we'll talk about Mercury, Venus, and Mars. We have talked about them in the past, but we will review. And also, we actually did not talk about Mercury, so we will definitely do that right now. So, Mercury, again, the smallest one, it is 0.056. So, the fraction 0.056. That's so tiny. That is the fraction of the mass of the Earth. That is the mass of Mercury. Mercury is difficult to observe from the Earth because it is never more than 30 degrees away from the Sun. Aha. So this difficulty led to early mistakes about its rotation. Prior to so the Sun, and because Mercury is close to the Sun, and this proximity of the angle as well, never more than 30 degrees away from the Sun, actually makes it kind of difficult for us to observe Mercury because the Sun is right there. This difficulty led to early mistakes about its rotation. Prior to the mid-20th century, it was thought that Mercury was in synchronous rotation, with one side always facing the Sun, just as one side of the Moon always faces the Earth. So yeah, another fact, which is that the same side of the Moon faces the Earth because of the rotation period of these things. The true rotation period was discovered using radar astronomy. The rotational Doppler broadening gave the rotation speed, which when compared with the known radius of Mercury, gave the sidereal rotation period to be 58.65 days. The sidereal orbital period of Mercury is 87 days. So the sidereal orbital period of Mercury is 87 days, which is not that much, not too long. But the P rotation is 58.65 days. So P rotation is around 2/3 of this sidereal orbital period, or P or orbit. In other words, during the time it takes Mercury to go twice around the Sun, it completes 3 full rotations about its axis. Pretty interesting, right? So same time that it takes to go twice around the Sun. So like it goes twice around the Sun as in its year, like the Mercury year, is only, like our year is 365 days, right? So that's quite long compared to Mercury's only around 88 days. So it goes twice around the Sun, but in the same time, it completes only three full rotations about its axis. How very slow, basically, right? Very slow rotation. The length of the solar day on Mercury is thus 175.9 days. Goodness. Because of the large eccentricity of Mercury's orbit, so its eccentricity is 0.206, and we will talk about this in a little bit. We will compare all the eccentricities. Because of this large eccentricity of Mercury's orbit, observers on Mercury would see a great variation in the angular speed of the Sun relative to the horizon. So the rotational angular speed of Mercury is constant with omega rotation. So sometimes we give the symbol of omega, which is like a little W. It looks like a little curly W, just so you know. So here we're saying that omega rotation is equal to 2 pi over P rotation, which we know P rotation was 2/3 of the P orb. And all that comes into saying that the omega rotation is 1.5 of the omega orbit. So all of that leads to some more math, and the angular speed with which an observer on Mercury, so if you were on Mercury, what would your experience be looking at the sun and things like that? Because you're close to the sun, your own rotation on your axis is kind of slow, but you go around the sun pretty fast. So the angular speed, pretty fast as in actually really fast. The angular speed with which an observer on Mercury sees the sun move relative to the horizon is the same as the angular speed of Mercury's rotation as measured in a frame of reference co-rotating with a line drawn from Mercury to the sun. Huh. Interesting. So when Mercury is at aphelion, so farthest away from the sun, an observer on Mercury will see the sun move relative to the horizon with angular speed of around 0.83 omega orbit. So, or about 3.4 degrees per day. So that's basically the angular speed at which the sun will move is about 3.4 degrees per day. Wow. When Mercury is at perihelion, which is the closest to the sun, closest to the sun. So when Mercury is at perihelion, closest to the sun, an observer on Mercury will see the sun move relative to the horizon with angular speed of around 0.2 degrees per day in a retrograde direction. So how strange. So 3.4 degrees per day of sun movement when it's at aphelion, and 0.2 degrees per day in a retrograde direction, as in it's going backwards. So, goodness gracious, very different experience if you were an observer on Mercury versus, of course, if you're an observer of the sun on Earth. That is, at perihelion, an observer will see the sun seize its usual east to west motion. So stop its east to west motion relative to the horizon and move slowly from west to east because it's retrograde. So very, 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 very different, right? Very different. So again, at perihelion, an observer on Mercury will see the sun stop its usual east to west motion relative to the horizon and move slowly from west to east. The rotation period, P rotation, and orbital period, P orbit, of Mercury are commensurate periods. That is, their ratio is equal to the ratio of two small integers. Well, we saw that because it's like 2/3, right? 2/3, two small integers. So I like how the author wrote this, two small integers. The commensurate periods of Mercury are a consequence of Mercury's eccentric orbit, combined with the fact that Mercury is slightly prolate rather than perfectly spherical. So its shape of its orbit, it's not perfectly spherical. The prolate shape of Mercury means that we can think of Mercury as having two permanent fixed bulges, in addition to the changeable moving tidal bulges raised by the sun. So we can look at a figure for this in a second here, but basically one or the other of the permanent bulges always points toward the sun when Mercury is at perihelion. In addition, because the rotational angular speed and the orbital angular speed are nearly equal around the time of perihelion, the bulges remain pointing close to the sun for the entire time that Mercury is nearest to the sun. So its orbit too is kind of unique, kind of really unique. This makes the commensurate relationship, which is that ratio of 2/3, like 2/3, is two small integers. That's what that means, right? 2/3 is not like 2/3 is basically pretty close to 1. Not very close to 1, but it's not very small, very much smaller than 1, for example. This makes the commensurate relationship between the orbital and rotational periods very stable. So this type of thing where the orbital and the rotational periods are commensurate or similar or whatever, that's rare. Okay, that's really a Mercury thing. So this makes the commensurate relationship between the orbital and rotational periods very stable. If Mercury's rotation rate were to slow down even more, it's pretty slow, I feel, on its axis, then the bulges would be misaligned at perihelion. The gravitational forces exerted by the sun on the permanent bulges would then torque up Mercury's rotation until the bulges were again aligned at perihelion. The misalignment of the permanent bulges near aphelion is not as physically significant since the gravitational forces are smaller at aphelion than at perihelion. So, of course, at aphelion, it's farther away from the sun. The gravitational forces are going to be smaller than at perihelion, of course. And, Mercury being so close to the sun, these gravitational forces are substantial. The gravitational effects of the planet Mercury on the spacecraft Mariner 10 and Messenger have allowed astronomers to compute the mass of Mercury accurately. So, Mercury being so close to the sun and being kind of difficult to observe and things like that actually means that measuring its mass is not going to be the easiest thing in the world. So we had to do it by sending spacecrafts towards it, and the effects of Mercury on those other things, that is Mariner 10 and Messenger, that's actually how we compute the mass of Mercury. Now, of course, remember, if Mercury had its own satellite, such as its own moon, then we could also compute something about its own mass via its moon. We will see how, the effect that somebody has on, and by somebody, I mean a planet, in this case, or in certain cases, a star, if we're talking about the mass of the planet. But in this case, we are talking about the mass of this planet, but it does not have any moons. Mercury does not have any moons. So it's not like we can see the effects of Mercury on its moons. We had to send a human-made satellite to kind of get its own mass. So the gravitational effects of the planet Mercury on the spacecraft Mariner 10 and Messenger have allowed astronomers to compute the mass of Mercury accurately despite the fact that it has no natural satellite. So that's what I was just saying. It has no natural satellite, meaning it has no moon of its own naturally. The mean uncompressed density of Mercury turns out to have the remarkably high value of 5,400 kilograms per meter cubed. So we actually talked a little bit about this already. We saw that there were certain numbers we were comparing for the uncompressed density of the planets. And so we know. And actually, some of those densities also affect certain other things, etc. But we will now discuss this in a little bit more detail, where the mean uncompressed, so this uncompressed, what that means is that does not take into account gravitational compressing. If your own mass is very large, like the Earth, in comparison to Mercury, your own gravity will actually compress the density or your mass density more down to something a little bit less. Or sorry, a little bit more. So then we have this other more standard number, or let's say calibrated number, which is the uncompressed density, so that we understand the makeup of the different planets. Basically, we are interested in understanding what makes up Mercury versus Venus versus Earth. But we know that Earth has a much larger mass, for example, than Mercury. So we should compare their uncompressed densities. So that's what this is about, okay? So the mean uncompressed density, so this has nothing to do with the compression due to gravity, just the mean uncompressed density the mean uncompressed density of mercury turns out to have the remarkably high value of 5,400 kilograms per cubic meter. So density again is given by, of course, a mass divided by a volume. And in the scientific units, that is given by, kilograms is the mass unit and volume is cubic meter here. Okay, so meter cubed. So 3 meters, 3 lengths is a volume. So this density of 5,400 kilograms per meter cubed is the uncompressed density of mercury. And we actually saw earlier that the uncompressed density of Earth, I believe, was, what was it? It was like 4,200, I believe. Let me make sure that I'm saying that right. You know what? There was a little table, and we covered it the other day, but I want to, oh yes, there we go. We covered it the other day, but I'm doing it, doing this live, sort of, not assuming that everybody saw that other one. So the uncompressed, so just to give you an idea, the uncompressed densities of terrestrial planets, Mercury we just saw is 5,400 kilograms per cubic meter, and comparing that to the Earth's is around 4,200. So Mercury is actually remarkably dense, remarkably. It is remarkably high value, has a very high value of this uncompressed density. This indicates that Mercury has an unusually large iron core. So speaking of, as that kid maybe here, yeah. Yes, Madeline, are you still here, my love? I think that we lost her. Yes. Let's assume Doro jumps into a wormhole, which opens into the room of Batman. Okay. Kaya! Hello! Hello, my friend. How are you, Kaya? Maybe Batman was that quiet kid in class. Truthfully, I don't even care. Kept cursing, told him not to. Yes. Thank you. I'm so sorry we lost her. Well, I mean, I hope she's around and may come back. Kaya, hello. No, long time no see, Kaya. So yes, Kaya is also one of my afternoon VIPs. Continue, Miss Neil DeCrass. Okay, thank you. Nausat, hello, hi. Hi, Nausat. Hi, Kaya. Hi, Madeline. And Yash, if you're joining, hello to you too. I know it's nighttime in Pakistan, so sometimes the kids are already asleep at this time. But sometimes there's a bunch of kids who join from the US and Europe time, actually, at this time, because they like the cats. So, yeah, okay. So this indicates that Mercury has an unusually large iron core. So remember how I mentioned these planets are rocky and metallic. So these, what we call terrestrial planets that are close to the sun, Mercury, Venus, Earth, and Mars, we know, you'll see how there's more things and more analysis to be done about them, but we know that they're rocky And we know they have some metal, but we don't know necessarily, we wouldn't necessarily know how much, or it's not generally obvious. But once we measure things and we find a way to measure things and we find a way to get their mass, such as by sending like an artificial satellite, if it didn't have its own moons and things like that. Mars, for example, it's smaller than Earth by a lot, but it has its own moons. So that's very helpful, Earth, of course, Earth, obviously, as you know, we have a very lovely moon. It's actually one of the biggest moons of the solar system. Not the biggest, but it is one of the bigger moons in our solar system. But Mercury has no moons. So we had to send the artificial satellite to get a feel for its mass. And little by little, we basically figure out more things about these planets that are other planets even in our own solar system. Not everything is totally obvious. All we know is that there is this object in the sky. It seems to also go around the sun. But there's a lot of details which would be more mysterious until you do the proper exploration and research. So, yes, hello, Steven. Hi. I think the kids, I don't know how many kids are really here anymore because the kids are usually very active in the chat. So if they're not saying a lot of stuff, then they might not be here anymore. Steven, hello. Indian American, yes. Yes, indeed. That is what I am. So, yeah, I should have started the live even a little earlier because around 1 p.m. or so, I think is when they join more. And if the kids were here, you would see them. They'd speak a lot to each other. So it's 1:20 a.m. here. Yeah, is that in India, you mean? Yeah, so sometimes at this time, I also get a lot of people from India and Pakistan, sometimes a little older kids, not the very young kids, like the 8-year-olds and 9-year-olds and 10-year-olds are generally in bed by now in those countries. But I get maybe teenagers at this point. She's Belgian. That's true. I am Belgian. Yes, we've been talking about that. Exactly. We've been talking about we just covered the rotational periods, the two different rotational periods, on its axis as well as on or around the sun. So now we're talking about how Mercury has an unusually large iron core. To give Mercury an uncompressed density, oh yeah, I forgot. The British kids might be joining soon. So I know sometimes around this time also the UK people join, and some of them are also young. So yeah, this indicates that Mercury has an unusually large iron core. To give Mercury an uncompressed density of 5,400 kilograms per cubic meter. So a tiny planet like Mercury, to get that 5,400 kilograms per cubic meter, a skimpy 600 kilometer thick mantle of rock must lie atop an iron core with a radius of 1,800 kilometers. So Mercury has a gigantic iron core. There is a very skimpy, let's say thin, 600 kilometers thick mantle of rock. So how big this mantle is, of course, is also different for the different rocky planets. You will see Earth mantle is different, Venus mantle, But it looks like, goodness gracious, Mercury's iron core is 1,800 kilometers of radius. So that's huge. the iron core is a lot bigger than that mantle of Mercury. So the core is in the middle, and then there's the mantle, right? So the disproportionately large core may indicate that Mercury was once more massive, but then lost most of its mantle in a large protoplanetary collision, similar to the collision in the giant impact theory for the formation of the moon. So one of these nights, we talked about the formation of the moon and how there are a few different theories. It's difficult to know exactly what happened, but there are a few different theories. And, we talked, there was one which was quite compelling, where we basically said something might have collided with the Earth and contributed to a larger iron core of the Earth, and the stuff that ejected out was mostly rocky, and that is the current moon now, and that part does not have that iron core. And so the moon rockiness or density or material is significantly different than the Earth rockiness. So, and it does not have, just turns out, it does not have the same level of diversity in its rockiness as the Earth does. So, that's one theory. But because Mercury has such a humongous iron core, it's almost gives us some pause and makes us think that maybe it was once more massive. And now that I'm thinking about this as well, those hot Jupiters I mentioned in one of my lives earlier, where, we are looking for exoplanets, right? Planets that are outside of our own solar system, or exoplanets. This is in relation to our interest in finding alien life. Alien life could be any type of alien life, really doesn't have to be human being, or, it doesn't have to be anything like people, humans, cats, dogs. It could be just some other life form that's alien, meaning it's outside of Earth, and especially in other completely different systems, or star systems, or other planets, exoplanets outside of our solar system. Now, we would look for planets around some other stars completely, because, well, those planets would need some form of, energy, power. Life doesn't just happen, without, like, look at this. Like, look at this sunny day. The sun is giving us so much heat and energy, and basically what gives us life. And so we look for other stars that could be kind of like the sun, or maybe different from the sun, who knows. And we look for planets around those other suns, let's say, or other stars, not our sun, but other such suns. And what we found is more Jupiter-sized planets. Those are also more easier to find because they're bigger. And I'll read about this. I'll tell you about this more later. But basically, we found a bunch of hot Jupiters. That's one name that we give it. And so these are big, right? And I wonder, we're seeing everything as they are right now for our own solar system. And I mean, human beings are only like thousands of years old. Things have been happening for billions of years in this solar system. As we know, it's around 4 billion years that this solar system has been around and doing stuff. So a lot could have changed over time, and it could be that Mercury was once more massive. So the disproportionately large core may indicate that Mercury was once more massive. But then lost most of its mantle in a large protoplanetary collision. So that could have happened. And similar to the collision that we talked about with our own moon, the way it could have come to be. At first glance, the surface of Mercury is similar to that of the moon. So when we first think about, actually the moon is kind of small too, right? So at first glance, the surface of Mercury is similar to that of the moon. The primary surface features are impact craters. So the primary surface features, like the main, what's the main feature on the Mercury's surface is actually these impact craters. And we talked a lot about these impact craters as well in relation to our own moon the other night. The largest impact crater on Mercury is called the Caloris Basin. This is spelled as Caloris, Caloris Basin, and it's approximately 1,300 kilometers in diameter. Wow. This impact crater, Caloris Basin, is approximately, again, 1,300 kilometers in diameter. However, Mercury does have some unique features that are not found on the moon. So we talked a lot about the impact craters on the moon and how those were probably formed during a certain period of this solar system where we had a lot more smaller objects and debris still kind of just flying around. And eventually all of this was swept up and contributed to planet formation, and there was basically like a sort of a spring cleaning or house cleaning of this solar system where we now don't have as much smaller objects and debris, and we can think of that time as sort of the part of the formation. So we talked about planetesimals, little planets, planetesimals. Basically, these in this previous live, we talked about how the solar system forming is sort of like this massive condensation of a very massive gas cloud in this galaxy happening over time, over a long time. And some of the smaller the biggest condensation is the sun, and some of the smaller ones are really the planets that we are now on, or this planet that we're now on and the other planets. But basically that wasn't it. Pretty much as things were still kind of condensating rather, and there were these what we called planetesimals, which are not really full-on planets, but the stuff that will eventually will impact things or get absorbed, let's just say, by these, bigger, more defined planets as time goes by. There was a big sort of that sort of thing happening at one point during our evolution of this solar system. And impact craters were formed during that time. So, in fact, there was let me just read about it real quick from the moon part, because we talked about it a lot. So, oh yeah, let me just read this part real quick because hi Shona, hi Fuji baby, hi Suji mama, hi Baji baba. So let me read about this impact crater thing real quick. There was here it is. So we talked about these large impacts happening in relation to the moon. So let me cover this part real quick so you know in general why we got impact craters as we talk about the impact craters on Mercury. Very large impacts can fracture the lunar crust. So at this point, we're talking about the moon to a great depth and allow subsequent flooding by molten rock from the mantle. This is how the Maria were formed, the Maria on the moon in this case, on our moon. The difference in cratering between the relatively smooth Maria with ages averaging 3.5 gigayears or 3.5 billion years, and the crater-saturated highlands with ages averaging 4.0 gigayears or 4 billion years shows that an era of heavy cratering took place more than 3.5 gigayears ago. So this is the part where we talked about this, where it's this, we call this the period of heavy cratering. When this was happening and impact cratering was happening on the moon, similar at that same time, similar methods would have led to these impact craters on also Mercury, which is what we're on right now. This is about the time the solar system was being cleared of remaining planetesimals and debris after the formation of the planet. So this is what I was saying a while ago, but I wanted to reiterate it, that there were these remaining planetesimal, smaller objects, debris in the solar system, and there was this period of clearing happening. And in addition to the moon, all the terrestrial planets underwent the heavy bombardment. So literally, the debris is hitting you, all these planets, all these, even the moon, for in our case, our moon, and all this heavy bombardment, and all bear the scars to a greater or lesser degree. Basically, all the planets and moons may or may not have such scars, basically, from the heavy bombardment period. Yes, kitty cats are enjoying. Kitties are learning too. Yes, kitties are learning about the planets. That's what the live is. And so are you. So, the Earth seems less affected than the other terrestrial bodies, but this is simply because erosion by wind and water is more efficient on the Earth and has obliterated craters that formed long ago during the epoch of heavy bombardment. This is exactly what I was talking about in relation to Mercury today, which is that there was a period of heavy bombardment pretty much more than 3.5 billion years ago. This really impacted, quite literally, our own moon as well as the other terrestrial bodies such as Mercury. And it impacted our Earth as well, but our Earth is very efficient in terms of, well, our Earth has a bunch of water, oceans, right? And it's efficient with kind of obliterating these craters because there's erosion by wind and water, and more surface features have basically taken away some of these impact craters on Earth, as more surface features have evolved over time since that time. So we might not know about these or see these too much on Earth, but these are definitely a thing on the other rocky bodies of our solar system. So that's what I wanted to mention. There was a period of what we call heavy bombardment that led to the impact craters. Now coming back to our topic of Mercury, the largest impact crater on Mercury, the Calories Basin, is approximately 1,300 kilometers in diameter. However, Mercury does have some unique features not found on the moon. Mercury has linear features called scarps. So almost like scars, but scarps with a P in the between R and S. So SCARPS is scarps. So Mercury has linear features called scarps, these are basically cliffs. These are cliffs that can be hundreds of kilometers long and as high as 2 kilometers. Holy crap. Hundreds of kilometers long cliffs and as high as 2 kilometers. That's quite high. The height of the scarps combined with the low surface gravity of Mercury means that if you slipped from the top of a scarp with a height of 2,000 meters or 2 kilometers, you would fall for a long time. Goodness, I forgot about the very low gravity on Mercury. Of course, it's small in mass. So you would be falling for 33 seconds if you were to fall from such a cliff, which is 2 kilometers in height. And because the gravity on Mercury is, of course, a lot weaker than the gravity on Earth, so you have a view of hopefully something you like for 33 seconds before you hit the ground on Mercury. So by the time you reached the base of the scarp, you would be traveling at a speed of around 120 meters per second or 440 kilometers per hour, an unhealthy speed at which to slam into a solid rock. So it's still pretty high velocity to be hitting the base with, to be hitting solid rock with, because Mercury is solid rock. So yeah, not good. You would be falling for 33 seconds, but because that height is pretty big, 2,000 meters or 2 kilometers of height, you're traversing with a different gravitation acceleration. So it takes you 33 seconds to, no, it's, oh, sorry, yes, 2 kilometers high, whatever that is in miles. It would take you 33 seconds to hit the ground at a speed of around 120 meters per second. So pretty unhealthy speed, would probably kind of hurt to slam into the solid rock with. The long, tall scarps on Mercury, so long and tall. Long as in literally hundreds of kilometers long, and 2 kilometers high. The long, tall scarps on Mercury were due to shrinkage of the planet's core by a few kilometers as it cooled. So Mercury's cooling is, of course, different as well because it's so small. Because it's a smaller planet, we would assume, even if it was bigger in the past, its cooling may have happened in a more dramatic manner. And excuse me, and the long, tall scarps are a result of this shrinkage of the planet's core by a few kilometers as it cooled. As the planet cools and it goes from more molten-y to more cool-y, it will shrink, right? Cooling means it will shrink. And this kind of shrinkage led to these formations, the scarps, which are these big, long, tall cliffs. Unlike the highlands of the moon, so by the way, we talked the other night about the highlands on the moon as well. The moon has some features as well, Marias, highlands. And because the Mercury is so small, I think we're comparing it sort of to our own moon. Unlike the highlands of the moon, the surface of Mercury is not totally saturated with craters. This implies that the solid surface of Mercury formed near the tail end of the era of heavy bombardment. That's right. So our moon has a ton of craters. So it was really affected by really affected by the heavy bombardment or the era of heavy bombardment, with a ton of craters forming on its highlands. But Mercury does not have as many craters as our moon, so we think that that would imply that the solid surface of Mercury formed near the tail end of this era of heavy bombardment. Because of its high... Oh, kitty cat. Kitty cats, kitty cats, kitty cats. Little baby. Little baby. Because of its high subsolar temperature and its low escape speed, Mercury has no permanent atmosphere. So I think Stephen Spears was asking about the atmosphere of Mercury. We're gonna talk about that. Doesn't Mercury have a thin atmosphere? Yeah. So because Mercury is very small in mass and it has a high subsolar temperature, so it's not as hot as the sun. But remember how close it is to the sun. It is, again, 0.39 astronomical units away from the sun. So very hot, very, very hot, but very small. Because it's so small, it did cool, but it's still kind of hot in terms of its surface temperature because of its closeness to the sun. Tenuous thin atmosphere. Okay, so because of its high subsolar, oh, look at Baji. He's kind of enjoying the sun, but his face is buried in his hands. Look at my Baja. Look at my Baja, as in Baji Baba. My Baji Baba, little baby. So because of its high subsolar temperature and its low escape speed, Mercury has no permanent atmosphere. However, it does have a transient tenuous atmosphere consisting primarily of sodium and oxygen that's released when micrometeorites vaporize bits of Mercury's crust. So, as Stephen was pointing out, there is this thin, tenuous atmosphere. It's transient, as in it's not constantly there. So permanent means a permanent atmosphere. It's always there, like we have one. Transient means that it sometimes gets transient-like, temporary atmosphere. So it has a transient or temporary nature type of tenuous atmosphere consisting primarily of sodium and oxygen that's released when micrometeorites, again, small little objects, will actually vaporize bits of Mercury's crust. So these things will hit Mercury and vaporize its crust and give it a transient tenuous atmosphere. How interesting. In addition, there are traces of hydrogen and helium from the solar wind. So yeah, we should remember also, of course, sun is mainly hydrogen and helium. Mercury is so very close to the sun. So not surprisingly, there are traces of hydrogen and helium from the solar wind, which is, of course, going to be so much more important at Mercury than, say, for us, trapped temporarily by Mercury's magnetic field. So again, Mercury has that very gigantic iron core, apparently. It does have a magnetic field, and this solar wind does get trapped by Mercury's magnetic field, and also gives it a bit of a atmosphere-y type of thing. So there's that as well. Mercury. Does Mercury have anything to do with the element Mercury? That's a great question. I'll have to look into that before I say something. Yeah, I should look into that. Thank you for the question. So Mercury's magnetic field strength measured at the surface of the planet is 3 times 10 to the negative 7 Tesla. So as you know, magnetic field, the unit of magnetic field in scientific units is Tesla, named after, of course, famous scientist, very awesome person Nikola Tesla. So in addition, so again, there are traces of hydrogen and helium giving it a transient atmosphere as well from the solar wind being so close to the sun, and also because it has that magnetic field. And this magnetic field strength on Mercury is only, or it is not only, but it is 3 times 10 to the negative 7 Tesla, which is actually quite a bit. So that is approximately 0.01 the magnetic field of the Earth, which is pretty strong for such a small, slowly rotating planet. Because remember, Mercury's rotation on its axis is so slow. It's almost commensurate or comparable to its rotation around the sun. That was the discussion we just had in the beginning. So, as you know, being a metal and then rotating on your axis, or having a ton of metal and then rotating on your axis, will give you the magnetic field. So, this is another evidence, basically. So, Mercury's magnetic field strength measured at the surface of the planet is 3 times 10 to the negative 7 Tesla, which is surprisingly strong magnetic field for a small, slowly rotating planet. Mercury's magnetic field, like that of the Earth, is strong enough to prevent solar wind particles from striking the planet's surface. So sometimes the hydrogen-helium traces are there from the sun, but also, depending on what type of charged particles, it can also prevent solar wind particles from striking the planet's surface. So some things may get trapped, and some things may even be avoided. So it's very interesting. I think this further shows that Mercury has a very large, strong iron core. It's very metallic. And even though it's small and slowly rotating, its rotation on its axis is very slow compared to the other rocky planets. But it still has a significant magnetic field. And let me, oh yeah, I already told you, it's 0.01, the magnetic field of the Earth. So, Stephen, report whoever you want. Don't wait on me. Oh, thank you. Yeah, no worries. We get all kinds of people. Silly question, does the planet Mercury... So Ajay asked if the planet Mercury have anything to do with the element Mercury. And I think I don't know. I know that Mercury, the planet, in astrology has certain other meanings. And sometimes we say mercurial, mood or temperature, So I don't know. And mercury, of course, was used to measure temperature, the element mercury. So there might be a connection between the planet Mercury and the element mercury in terms of an astrology connection, but I don't know. I'm just making a guess. Here's your warning. Okay. Well, let's see. Yeah, so good question. It has a magnetic field, which also helps to protect it from certain solar flares, as we just saw. Harper, hello. Hi, Harper. Hi, Stephen. Hi, Harper. Hi, Ajay. Hi, Doro. Hello, Stephen again. Hello to everybody on the chat. Thank you so much for being here. I see a lot of things going on. Thank you for modding, and thank you for joining the chat. Really appreciate it. Steven says, or I hear you, be back in a bit. This is a clean family chat. Yes. Yes, this is a clean family chat. Try to hold off on sort of non-family friendly things, I'll pass out listening to the stream. It's 2 a.m. here. Yeah, go ahead and close your eyes as you listen to us talking about astronomy with the kitty cats. This is meant to be soothing, relaxation, peaceful, live, with some information and value add about the planets today. We talk about physics, astronomy, and cosmology mainly on the live. Lately, we've been talking about, oh, hello, Dr. Cias is back. So I'm putting you in timeout for 24 hours. Oh, I see. Dora, yes, okay, we both did it. So Dr. Cias is timed out by 86,000 seconds. So good. Hi, Harper. Hi, Doro. Hi, Ajay. Hi, everybody. Yes, feel free to pass out as you listen or play video games or whatever you're doing. We have been covering these planets and moons type of topics recently. In the past, we've also covered cosmology. We actually got into the gory details of certain equations to do with our universe as well at one point. But I felt that the planets are more kids friendly. Everybody needs to learn about the planets, right? And a lot of kids join during the afternoon, usually. I don't know if I lost all the kids today because of what's been kind of going on, or because they have given up on me. I tried to look it up, and I know Mercury is a planet and is also known as quicksilver and a liquid element. Yes, so the element mercury is called does have the symbol Hg and is a liquid element. That's okay. That's all right. I hit 24 now too. Okay, cool. Thank you. Ooh, can we get 20 likes? Thank you everybody for liking the live. Could we get 20? Could we get 20 likes? Harper says, did you see what I did? I thought I had timed them out. I thought I had timed him out, but then it came back and then I think we both did it. So me and Doro both timed him out. So I don't know if that means that they can still be on the chat. Like, can they still listen to the live or not? So Dr. C is, if you're still here, keep on listening to the live and learning about planets. As you can see, the kitty cats are still listening. They can listen. Oh, how interesting. I could see how if they wanted to say things in the chat, they might leave now, but it's fine. You have a soothing voice like the radio. Yes. This channel kind of started with the kitty cats and my voice, actually. Usually didn't used to show my face in the past because it's kind of soothing to do the voice, material, basically. And it's nice. And the kids actually like the cats more. So here we are. And you can see the kitty cats learning about the planets. So anyway, that's all I had on Mercury. Next, we will talk about Venus. We kind of covered Venus the other day during a night live, but that's okay. I think it was a very, very interesting planet. So we will do it again. We will cover Venus again. And hopefully you will learn about something new with Venus. And the very interesting thing about Venus is that it's in many ways very similar to the Earth. So oh, Dora's about to leave, but yeah, okay. You have a soothing voice. Yeah, this is going to be the radio style live today. Oh, thank you for liking the live. Thank you for liking the live. I see the 21 likes. Thank you so much for being here. We're teaching planets to the kitty cats and to you. This is a voiceover video right here, actually, if you didn't notice. So so much more than the cats, indeed. So here's the cats, and here's the voice, and here's some more things about planets. I will now take a break. Dora will tell you that these breaks are sometimes indefinite, but that's not the case. I'm just going to be right here, actually. I want to make a coffee. We just finished Mercury. Do you even understand English? Just record yourself yelling that. No, seriously, yeah. These people, Doro has seen all kinds of sides of me, even some very different side. This is the radio side of me. Calm, soothing, relaxation, peaceful content about planets. But a different personality is sometimes available as well. 45 minutes water break. Doro, play your video games. Everybody, continue to chat in the chat. Drink some magical potions. I need to make a coffee. Otherwise, a different personality might come out. So keep on chatting in the live. I'll leave you with the, I mean, I won't leave you because I'll be right here see, right there. Do you see my coffee? Right there. So it's going to be right here that I am. So hang tight. Hang tight. Hang tight. No, I can't do a 3-hour water break because I have dinner plans. I do have a life sometimes. So I have dinner plans. I can't be here. I can't be here for 3-hour water breaking. I love Venus as much as I do Mercury, just as big around as Earth. Yes, almost as big as Earth. So Venus, remember, is 0.82 the mass of the Earth. It's very similar to the mass of the Earth. Plans all week starting Monday. Yeah. So no, I have dinner plans tonight, but I'll probably be back on the live tomorrow evening, you know. But I have to go to Little Italy tonight. So I will not be here tonight, but tomorrow probably definitely will do another live during the evening. Okay. Before I become a more aggressive personality, let me get a coffee. You guys hang tight. Hang very tight. Thank you so much. Oh, and look at this new angle of kitty cats. Shona Fuji. Oh my god. Oh, they're all getting up. They're all getting up. They think they're gonna get a snack. Hi, Fuji sweetie. Come. You can get a snack. You can. Look at what's happening here. They all want a snack. Little babalogs. Plans all week starting Monday. You guys behave. I'll be in Mississippi. You guys come find the talking anim cat. I'll be there. I keep getting lag when I send a text. Fuji Baji, Karana Shona. You'll be in Mississippi? Oh my gosh, that's one of the states I haven't been to yet. It's on my list. Fuji Baji, don't fight. Shona, Karana Shona. Okay, let me give them a little bit more snack. They seem to be wanting it. Here, Baji. Okay, you can see that view while I make the coffee. Woody Baji. Oh, so I forgot that there were the cooking and baking comments or something. I think people want my soothing voice with a baking video. Oh gosh, oh gosh, oh gosh. I almost tripped. Oh my gosh, you guys. Mississippi is about to kick off. Lots of huge projects heading that way. Yes, I would. Apparently, Venus is very poisonous indeed. Okay, hang tight. You guys keep on talking. Keep on talking and look at this Baba. Look at this Baba, touch wood, and thanks to the universe. You're a baby to me. You're a good baby. Such a good. Look at where you are, Fuji. Look at where you are. Look at where you are. This is my Baba who helps me with every kitchen stuff. Thank you, universe. Oh, you know what? 3-hour water break. 3-hour water break. I think we found a few more new people today. Hopefully these people are subscribing. Please do like, share, and subscribe. There could be water beneath the surface. Oh yes, that's right. We were talking about that the other day, about the polar. Yes, Steven. Look at that. Steven's been paying so much attention. Tell us, keep on saying more things, Steven. It's helpful. turn the dishwasher on. I have like no mugs left. I have no dishes and no mugs left. Fuji, have you helped me with the dishes today? Because have you helped me with the dishes today? Because I have no mugs left that are big mugs. And I need to run the dishes on the dishwasher because there are no like good dishes left either for their foodie. Steven made his YouTube home here, as he should. Aww, I'm so happy. This will be the YouTube home of everybody who loves astronomy, physics, kitty cats, cosmology, amateur astronomer. Yay! Steven, tell us something about your telescopes. Tell us. I think you have mentioned before, but tell us about your telescopes, Mr. Spears. Fuji Shona Karna. Look at this. Fuji's trying to help me with my coffee now. He loves the milk powder, so that's what this is about. If anybody ever heard of the face of Mars. Really? Wow. Oh. Look at where Baji is now. Baji Baba. Everybody is up. As soon as I'm up, they're all up. I didn't mean to disturb you, babies. Are you looking at me expecting a snack, Sachi? Sachi, Mama? Weren't you just now in the bathroom? Did you even finish? Did you wipe? Did you clean up after yourself? You're here expecting treat too when you were busy in the bathroom. Why don't you clean up now? Sachi Mama. They're always, this is why I don't get up. I can't get up because usually there's a cat on me. And when I do get up, their naps are disturbed when I talk about physics and astronomy. They're peacefully napping with my voice. But as soon as I'm up and about, they all wake up. Most unfortunate disturbance here for the babies. Thank you. Have a good trip, Doro. Jupiter and its 4 big moons. Yes. I hope you enjoy Mississippi and see you soon. Hi, Baji. Okay. Off. Off and off. Off and off and off. Look at us. We're about to start. Restart. We're about to restart. NASA says it was just a shadow and light effect. Yes, I have seen that too. The great red spot of Jupiter with my telescope. Can you fix it or not? Your telescope. This is the 5-hour water break. No, I'm back. Look at me, I'm back. It's not even 5 hours. So, indeed, we're back. And we're going to talk about Venus. We're going to talk about Venus with Baji. Y'all ready? Ready for Venus? Let me see. Where? Wow. I'm still reading the comments from earlier. I love how the Russians sent the Venera probe to Venus and landed probes on the surface. We only have 6 shots of the surface too. Okay, so we just wrapped up Mercury, which was a planet that we indeed did not cover on this channel until today. Some of the other things we mentioned, especially about the heavy bombardment period, or the period of heavy bombardment by the smaller objects, planetesimals, and debris in our solar systems, while it was still forming around 3.5 billion years ago time period, when things were still kind of happening, forming. Even now, I suppose, we are evolving. We saw that the moon, our moon, was heavily impacted by this heavy bombardment period and got a ton of impact craters. Same thing affected Mercury as well. Oh, good. Thank you. So a little bit of that discussion we talked about in relation to the moon earlier. And so hopefully that made sense today. And today, for the first time ever, we talked about this very small planet Mercury that we have now covered already. Now, in the past, we have talked about Venus and Mars, but I think they're so cool. And especially Venus is a lot like Earth in many ways, including its size is similar to Earth, often considered our twin in some ways. We will now talk about Venus today again, because I wanted this to be a family-friendly chat, afternoon live chat with the kitty cats, with the nice sunny day coming in. Generally, at this time, a lot of the kids join, and for them, this material may be new because they might not have caught it during the nighttime lives. So that's why we will go over Venus again. Oh, yes. We will talk about that one, Stephen. Yes. The bigger than the United States. Yeah. Or, well, yeah. Yes. Indeed. Grimmy, you are lame. Your middle name is lame. Grim, lame. Lame, grim. Hello. Thank you for joining. I am most thankful to everybody who is liking, sharing, and subscribing. Thank you indeed. Lame, tame, whatever it is, same. And that rhymes. Venus. So we will now talk about Venus. Oh, before that, let me real quick tell you something interesting, which I believe I didn't say yet, ever. on the channel. So let me try to tell you this information. I'm talking about everyone, myself included. Aw, Stephen, you're so sweet. Okay, where is this little information that I want? Aw, Stephen is the nicest, and he always contributes positively to the chat. Oh my God, Doro is back. I thought Doro went to Mississippi already. One last gift from me as Grimace. Well, Doro, have a good trip. Okay, this is crazy. I'm trying to find Hey, Steven, can you look up the size of our moon? But I want the accurate information. Steven, can you find what is the size of our moon? Okay, I was going to tell you the size of the moon compared to the planet Mercury, but I'm going to get back to that later. It's fine. I'm not going to do it right now because I'm getting distracted. So let's talk about Venus. So we talked about Mercury, of course, a small planet, very smallest planet of our solar system. We know that it is in mass only 0.056 the mass of Earth. And I was hoping that we will be able to compare it to the mass of the moon, actually. But I couldn't quite find that exact information right now where I was looking. So we will move on and we will cover the next planet, which is Venus, which has a mass of 0.82 the mass of Earth, or M Earth. So Venus is the most brilliant object, or the brightest object that we can see in the Earth's night sky, by the way, other than, of course, our own moon. So other than, of course, obviously, during the daytime, the brightest object is the sun. During the nighttime, if the moon is up, the brightest object is the moon. But with the exception of the moon, the brightest object in the night sky of Earth is actually Venus. So we will talk about this. Okay, so Venus is easy to observe at its greatest elongation of theta equals to 47 degrees. However, when we observe Venus at visible wavelengths, all we can see is a nearly featureless white cloud deck. So with our naked eye, we're basically seeing this featureless white cloud deck. Ground-based spectra, later supplemented by data from space probes to Venus, reveal that the clouds are made of sulfuric acid, which is H2SO4. H2SO4. So that's what we're looking at, really. The sidereal rotation period of Venus, like that of Mercury, can be determined by radar astronomy. We just looked at those periods for Mercury, and they were very interesting. If you go back into the live stream, if you're joining at this point, you can rewind and listen to what we talked about Mercury. But at this point, at this point, we will keep going. Venus turns out to be the slowest rotator of all the planets, with a sidereal rotation period, P rotation, of 243 days. So if you thought that Mercury's rotation was slow, well, Venus is even slower. So Venus is the slowest rotator of all the planets, with a sidereal rotation period again of P rotation of 243 days. Goodness gracious me. The rotation is not only slow, it is also retrograde. So we looked at a little bit of retrograde business with Mercury too. But Venus has some interesting things like this. The rotation is not only slow, it is also retrograde. That is, if we looked at the solar system from above the Earth's North Pole, we would see... Baji has gone to the bathroom. He will be back. Are you talking about... Okay. Goodness, Disco David, haven't seen you in a while. We did land on the moon is saying she won't thank me. But I thank you. Thank you indeed. Thank you for being here. The rotation is not only slow, it is also retrograde. That is, if we looked at the solar system from above the Earth's North Pole, we would see Venus orbiting in a counterclockwise direction. So this is new. Basically, there is something going on with Venus's rotation where it's kind of different. So if we looked at the solar system from above the Earth's North Pole, we would see Venus orbiting in a counterclockwise direction, the same as the other planets, but rotating in a clockwise direction. So it orbits in the counterclockwise direction, same as all the other planets. One second. Where is Baji Baba? So it rotates, or it orbits around the sun in a counterclockwise direction, same as the other planets, but rotates in a clockwise direction. Probably as a consequence of its slow rotation, which we saw is 243 days, Venus does not have a detectable magnetic field. So we saw that Mercury, even though it's small and even though it's a slow rotator, did have a significant magnetic field, which actually is helpful for it to save itself from certain solar winds. But Venus, with its even more slow rotation, being the slowest rotator, it does not actually have a detectable magnetic field. magnetic field. Because the orbital angular momentum and the rotational angular momentum of Venus are in opposite directions, the sidereal orbital period p rotation, and the solar day p sol are related by the equation 1 over p rotation is equal to 1 over p solar minus 1 over p orbit. And p orbit is 225 days is the orbital period of Venus, and so p solar is 117 days. I see. Got it. Yeah. So I was wanting to know, as a fraction of the Earth's mass, what is the mass of our moon? Could you find that out? I want to compare it to the mass of Mercury. Basically, the mass of Mercury is very small compared to the mass of the Earth. Mass of Mercury is 0.056 mass of the Earth. So 0.056 times mass of the Earth. So I want to know, what is our moon's mass as a fraction of the mass of the Earth? Thank you. Thank you. So basically, there's three things going on here. There's P rotation, that is the Venus rotational period. There is P solar, and which is the solar day of Venus. And then there is P orbit, which is the orbital period of Venus, with orbital period meaning its orbit around the sun. So it's P orbital, so a Venus year, P orbital, is 225 days. And because of all of the stuff we just said, there's the math giving us what is now P solar, and that number is 117 days. The surface temperature, so moving on to now its temperature. The surface temperature of Venus is high. So we talked about this during that night live. But basically Venus is very hot. So the surface temperature of Venus is high with a T of 740 kelvins, hot enough to melt tin, lead, and zinc. Despite the long solar day on Venus, the surface temperature is nearly uniform over the entire planet. This is because the circulation patterns in the thick atmosphere are highly effective at carrying hot air from the daytime side of Venus to the nighttime side, smoothing out the temperature differences. The high temperature at the surface of Venus is a result of the greenhouse effect. And this is very interesting because Venus, as you will find out, has this atmosphere filled with greenhouse gases that actually keeps it very hot. The sulfuric acid clouds of Venus reflect about 75% of the light that strikes them below the clouds. However, the atmosphere is nearly transparent at visible wavelengths. However, the energy absorbed by the planet's surface is re-radiated as infrared light, to which the atmosphere is opaque thanks to its high carbon dioxide content. So the energy is still absorbed by the planet's surface, and it's re-radiated as infrared light, to which the atmosphere is opaque, as in it keeps it trapped, thanks to its high carbon dioxide content. So if that's the case, then Mercury is smaller than our moon. So that's what the point I wanted to make earlier was that Mercury is really tiny. It's smaller than our moon. So the surface air pressure on Venus is P Venus of 92 atmospheres. So this is another big thing. Of course, because of this very extreme atmosphere, and all the heat and things and everything that it's trapping, and also the makeup of this atmosphere, the surface air pressure on Venus is 92 atmospheres, where, of course, one atmosphere is 10 to the 5 newtons per meter squared, and that is the average sea level air pressure on Earth. So you can compare sea level air pressure on Earth, which is one atmosphere, to the 92 atmosphere of pressure on Venus. The composition of the atmosphere on Venus is 96%, so around 96.5% carbon dioxide. So a lot of carbon dioxide, and 3.5% molecular nitrogen by number of molecules present. So by number of molecules present in the composition of the atmosphere on Venus, we have mostly carbon dioxide, which is 96.5%, and molecular nitrogen, which is 3.5%. There will be some really interesting facts that I say now, which will show you what a shame it is that Venus does not have oceans like us. So, one intriguing question is why the atmospheres of Venus and Earth are so different from each other. As you can see, if the Earth's atmosphere was mostly carbon dioxide, that would be really bad. But Venus and Earth are similar in other respects. So why does Venus have so much carbon dioxide remaining in its atmosphere? And why could it not be a little bit more like Earth? See you later, guys, for now. Okay, bye, Steven. See you later. So, one intriguing question is why the atmospheres of Venus and Earth are so different from each other. Venus and Earth are nearly twins in radius. So, the radius of Venus is 0.95, the radius of Earth, and the mass is around 0.82, the mass of Earth. So, very similar in these respects. Why then does Venus have nearly 100 times as much atmospheric pressure as the Earth? And the key difference between the two planets in this context is that the Earth has liquid water covering most of its surface. Carbon dioxide dissolves in water where it forms, among other compounds, negatively charged bicarbonate ions. So carbon dioxide plus water, which is CO2, carbon dioxide plus water is H2O, will make an H plus ion, a hydrogen ion, positively charged H plus HCO3 minus. So this HCO3 minus is a bicarbonate ion, and it combines readily. So bicarbonate ions, if you take a couple of them, they combine readily with any calcium ions dissolved in the water. So Ca2 plus 2HCO3 minus will give you carbon dioxide plus hydrogen carbon dioxide plus water, which is H2O, plus calcium carbonate. So once again, Ca2 plus 2HCO3 minus will give you CO2 plus H2O plus CaCO3. And this calcium carbonate, turns out, is going to be very important in making our atmosphere so much better, as you will see right now. Calcium carbonate is poorly, as in it's badly soluble in water, so it precipitates out to the ocean floor. Limestone, which occurs in abundance near the Earth's surface, is a sedimentary rock that consists largely of calcium carbonate. So the fact that it precipitates out of the water, it's not soluble, basically means that in this way, we're actually taking carbon dioxide out of the atmosphere and converting it into a form that contributes to the Earth's rock. So we don't have to breathe it. So since Venus is too hot for liquid water to exist, it lacks this mechanism for removing carbon dioxide from the atmosphere and locking it up inside rocks. If you could somehow remove the carbon dioxide from the Venusian atmosphere, The remaining atmosphere, consisting mostly of nitrogen, would resemble the atmosphere of Earth prior to the emergence of photosynthesis. Because remember, also, plants convert carbon dioxide and breathe out oxygen. So that has also helped with our atmosphere. And this initial too much carbon dioxide issue would basically be solved if Venus had a way of converting the carbon dioxide to some other thing like we do on Earth. We convert it to rock, or we trap it inside rock, and so that we don't have to deal with it in the atmosphere. Conversely, if you could unlock all the carbon dioxide presently contained in the Earth's limestone, the Earth's atmosphere would strongly resemble that of Venus. So we have our oceans to thank for our much more breathable, amazing, and livable atmosphere, which is not predominantly carbon dioxide. Because we have found a way to convert all of that carbon dioxide to a form which is much better for life. So that is the, I think, very, very interesting difference between Venus and Earth. They're so similar in certain respects, but so different. Really, that distance from the sun and its hotness, how hot Venus is, does not allow it to have liquid water. And that is where everything is kind of lost with Venus as far as life on Venus. And it's very sad indeed, because Venus is actually closer to us. So again, if you look back to the things I was saying earlier, Mercury is at a distance of 0.39 astronomical units from the sun. Venus is at 0.72 astronomical units. Earth is at 1 astronomical unit, of course, from the sun, and Mars is at 1.52 astronomical units from the sun. So, if I'm doing my math correct, I believe that the Earth and Venus are closer together. And so it would have been easier, I think, to go to Venus if it was more livable. But unfortunately, because of its extremely hot temperature, leading to no oceans, leading to a very poisonous atmosphere, we cannot live on Venus. So thank you so much for today, and for your attention, for being here on the live stream with us, for contributing your comments and messages to the live chat. I do have to get going today. The sun is down, and I wanted to utilize some of the sunny and good lighting to do this particular live stream with you guys, talking about kitty cats. Well, talking about planets and showing the kitty cats. I hope you enjoyed, and I hope I see you very soon for the next live stream. I'll see you next time. We will do probably an evening live stream again tomorrow. Venus sounds like a good home. Very nice.